Today we are going to create and solve an equation involving angles formed when parallel lines are cut by a transversal. In other words, we are going to prove that lines are parallel. First, let's take a look at some definitions and theorems that we can use to prove lines are parallel. The first is to show that corresponding angles, like the red star, are congruent, meaning that they are in the same location but a different group. I am circling all of the angles that are corresponding because they are in the same location but in a different group. If I was to pick up the top four and move it down, they would correspond with the angles on the bottom, proving that line AB is parallel to line CD. If I can show that alternate interior angles are congruent, then I can show that the lines are parallel. Alternate interior are angles that are in between the parallel lines and on opposite sides of the transversal. If I can show that the red stars or the blue stars are congruent, then I can say that line AB is parallel to line CD. If I can show that alternate exterior angles, those are angles that are outside of the parallel lines and on opposite sides of the transversal, are congruent, then I can state that AB is parallel to CD. If I can show consecutive interior angles are supplementary, that means that I have two angles that are in between said parallel lines and that they add up to 180 degrees, then I can say that the lines are parallel. If I have consecutive exterior, that means that these are outside of the parallel lines, but on the same side of the transversal. If they add up to 180 degrees, then we can say that line AB is parallel to line CD. Let's take a look at two examples where we are stating what type of relationship they have. We want to determine if the lines are parallel. Well, since 72 degrees is the same place, different location as 72 degrees, we can say that 72 degrees corresponds to 72 degrees. Therefore, line A is parallel to line B. In example 2, I want to move one of my angles, say 64, to a new location that is corresponding. And then I want to look at the relationship that exists with the 116. If I add those two together, they equal 180. So therefore, line A is parallel to line B, but only because 64 degrees corresponds to another location. Please pause the video and name each special angle and determine if the lines are parallel. In the first question, we can see that 52 degrees is vertical, so these are vertical angles. And we have not shown that vertical angles can prove that lines are parallel because they have no relationship between two parallel lines. They are just across one another when a transversal touches a line. So these are not parallel. In our second example to the right, we have 81 degrees and 99 degrees. If I was to move the 99 degrees to its vertical position, then I am creating consecutive interior angles. And if I can show that 81 plus 99 adds up to 180, then I can say that the lines are parallel. In our third example to the bottom right, we definitely have consecutive interior. And we want to show that 104 plus 75 is equal to 180. But when we add these together, we get 179. And since it's not equal to 180, we say that these lines are not parallel. In our last example, we have a linear pair because 78 plus 102 is equal to 180. However, linear pairs only show me that lines are supplementary, but not parallel. Now let's take a look at two examples where we're finding a missing value. In example 3, we want to find the measure of the missing angle that makes the two lines parallel. So since 108 and the question mark are corresponding angles, then we can say that the lines are parallel. In example 4, we want to find the value of x that makes the two lines parallel. I actually have too much information. I have this segment that is given to me that I don't need. So I'm actually going to cross it off. And I'm going to circle what I need, which is the 7x minus 3 and the 60 degrees. These are alternate exterior angles, which means that they are equal to one another because they are congruent. So I'm going to set 60 equal to 7x minus 3, and I'm going to solve for x. So 63 is equal to 7x, and x is equal to 9. If x is equal to 9, then that will allow my lines to be parallel. Please pause the video and solve these 4 example practice problems. In number 1, it wants us to find the measure of the missing angle that makes the two lines parallel. Let's figure out what type of relationship 94 and x have in common. They are alternate interior angles, which means that they are congruent. So x is equal to 94 degrees. And number 2, we have a lot of extra things that are here. We don't need this line right here. It's too much information. So we want to show the relationship between x and 53 degrees. Well, x and 53 degrees are alternate exterior angles, and we know that those are also congruent, so therefore x is equal to 53 degrees. In the first two problems, since we've shown that x is equal to its congruent value, then we're proving that u is parallel to v. In practice problem number 3, we want to find the value of x that makes these two lines parallel. These two angles are corresponding angles, which we know are congruent, so therefore 8x plus 11 is equal to 10x minus 5. We want to isolate our x, so we're going to move the 8x over from the left to the right. 11 is equal to 2x minus 5. Now we're going to add 5, so 2x is equal to 16. Therefore, x is equal to 8. And when x is equal to 8, it allows us to prove that line U is parallel to line V. In our last example, we again have an extra piece that isn't needed. I don't need this little segment, and I actually don't even need this line up here. It's just an extra line to throw me off. So I want to use line U and line V, and I want to see what type of relationship these have. These are, and I'm actually going to move the 17x minus 4 up. These are consecutive interior angles, and therefore they equal 180 degrees. So we want to add 8x plus 9 plus 17x minus 4 and set it equal to 180 and solve for x. So together, 8x plus 17 gives me 25x. 9 and negative 4 gives me plus 5 equals 180. We're going to subtract 5. So we have 25x equals 175. And we're going to divide by 25. And x is equal to 7. Just a reminder that ways to prove that two lines are parallel: if you show that corresponding angles are equal, or if you show that alternate interior angles are equal, if you show that consecutive interior angles are supplementary, or consecutive exterior angles are supplementary, you can prove that the lines are parallel.